So for example number 1, we are given the initial values. VO of 0 plus is equal to 12 volts and IL of 0 plus is equal to 30 milliamperes. The first is find the initial current in each branch of the circuit. Next is find the initial value of dV over dt. And lastly, find the expression for V of t. So we are given the initial voltage VO of 0 plus is equal to 12 volts and IL of 0 plus equal to 30 milliamperes. So first is find the initial current in each branch of the circuit. So we all know that IL of 0 is equal to IL of 0 minus is equal to IL of 0 plus. So since current in an inductor does not change abruptly. For the current in the resistor, we have IR equivalent to V over R. So for the initial current of R 0 plus equal to VO of 0 plus over R equal to 12 volts over 100 ohms equal to 3 milliamperes. To find IC or the current of the capacitor, perform KCL at the top node. We have IC plus IL plus IR is equal to 0. IC at 0 plus is equivalent to negative IL 0 plus minus IR of 0 plus equal to negative 90 milliamperes. So this is for A. For B, find the initial value of dV dt. We have to find dV at 0 plus, dV dt at 0 plus. Where do we get this value? So we all know that the current in a capacitor is equal to C dV per dt. So our dV dt 0 plus equal to IC at 0 plus over C is equal to negative 450 kilovolt per second. Now lastly, solve for the expression of V of t. First, let's determine the roots for the characteristic equation. So we have alpha equal to 1 over 2 RC. So alpha is 12.5 K rad per second. Resonant frequency is 1 over square root of LC equal to 10,000 rad per second or 10 K rad per second. Now since alpha greater than omega, the circuit is overdamped. For S is equal to alpha plus minus square root of alpha squared minus omega naught squared. So S1 equal to negative 500 rad per second. Then S2 equivalent to negative 20,000 rad per second. So our expression for V of t equal to A1 e to the negative 5kt plus A2 e to the negative 20k t volts. So how do we find the values for A1 and A2? So we need two equations. We have this equation. For the second equation, we need to get our dV, the first derivative of this expression. We have negative 5,000 A1 e to the negative 5k t minus 20,000 A2 e to the negative 20 kt. T equals to 0 plus, or V of 0 plus equal to 12 volts equal to A1 plus A2. We have our first equation. Our second equation, at t equals to 0 plus, or dv dt at 0 plus is equivalent to negative 450k equal to negative 5,000 A1 minus 20,000 A2. So, two equations, two unknowns. We can now solve for the values of A1 and A2. So, A1 is the value of negative 14, A2 the value of 26. So finally, our V of t is equal to negative 14 e to the negative 5 kt plus 26 e to the negative 20k t volts at t greater than 0. Or we can write this as in unit step. So V of t equal to negative 14 e to the negative 5 kt plus 26 e to the negative 20 kt u of t volts. So here is the graph for the equation V of t. So we have initial value of 12 volts, and the equation follows this line.